For my capstone project, I will be determining the structure for unknown A, which has a chemical formula C4H8O from the IR and NMR spectra. I started with the HDI calculation. I actually think this is the easiest way to identify a functional group in the spectrum. So if we multiply 2 times the number of carbons, which is 4, add 2, we get 10, minus the number of hydrogens, we get 2, divided by 2 equals 1 degree of unsaturation, and we discount for the O in our calculation of HDI. This could either mean 1 pi bond or 1 ring. So taking a look at our IR spectra, we clearly see at about 1730 wave number a carbonyl peak. This accounts for our degree of unsaturation, our pi bond in the molecule. And this peak is very significant because it can only mean a carbonyl group. Looking at our higher wave numbers, in between 3000 and 2850 inverse centimeters, we have our saturated, sp3 carbon-hydrogen bonds, or alkane portion of the structure. Again, very significant for us to determine what molecule this is. Finally, if we look just right to that, at between 2825 and 2700 inverse centimeters, we have our sp2 hybridized CH aldehyde. That's what these two peaks are. It's very characteristic of an aldehyde. So now we know that our functional group is an aldehyde, the major functional group in this molecule, aside from the alkane part. Looking at our 1H NMR spectrum, so actually I'm going to start at the 9.8 parts per millimeter peak, the 1 of 2 millimeters of integration. It's a singlet, and it is clearly the aldehyde hydrogen. Again, that's all that this can mean. It's a singlet because it doesn't is de-shielded enough to not account for any of its neighbors, and yeah, that's the aldehyde. So now if we look further upfield, we have a triplet at 0.9 parts per million with the greatest amount of integration, or the greatest peak, with about 14 millimeters. At about 1.8 and 2.4, we have a sextet and then a triplet respectively, both with integration heights of 9 millimeters. So our ratio of these two to this, we'll get into that on our next slide. It's important to note that I think that this triplet sextet triplet is actually pretty characteristic of a propyl chain. The triplet indicating 2 neighbors, the sextet indicating 5 neighbors, so 2 on one side, 3 on the other, and the triplet indicating 2 neighbors. So if we look at our integration, it's actually a little bit complicated if you do it based on the total amount of integration. So I actually discounted for the aldehyde. We already know this is a single hydrogen. It's actually much easier to account for the integration just in this portion. So if we have 9 millimeters times total integration, 9 plus 9 plus 14, or 32, multiplied by 7, again, we're discounting that aldehyde hydrogen. We have just shy of 2 hydrogens. The same goes for the 14 millimeter peak at 0.9 parts per million. That's just about 3 hydrogens. So now we know that our ratio of hydrogens is 3 hydrogens, 2 hydrogens to 2 hydrogens to 1, accounting for 8 hydrogens total. Therefore, and I'll get into this, we can determine that the structure is butanol or butylaldehyde. Our most upfield peak, these HA at 0.9 parts per million, again, it is a triplet, has 2 neighbors. It has the greatest integration because there are 3 hydrogens in this unique chemical environment. And it's the most upfield because it's furthest away from the carbonyl carbon. The HB, again, a little bit closer to the carbonyl and bonded to 2 C groups, 2 carbon molecules. It has 1, 2, 3, 4, 1, 2, 3, 4, 5 neighbors. So it's going to show a sextet splitting pattern. And it has an integration of 9 millimeters because there are only 2 hydrogens. Again, same integration, triplet splitting pattern because it has 2 neighbors. And it is at about 2.4 because adjacent to the carbonyl. Here's our aldehyde hydrogen. It's a singlet. It is the furthest downfield because it is least shielded. So if we reference this with an IR spectrum found online, we can see that butylaldehyde actually has an identical IR spectrum to the one given in the lab. Here's another one. This one's a little less clean, but we can clearly see the same functional groups, the alkane, the aldehyde, and the carbonyl. It's just drawn a little bit different. If we look at the NMR for butanol or butylaldehyde,